Hello, good morning. Welcome to today's webinar. We're going to present the new Beamform Global LOD specification, version 2223. We have the presence of David Merrifield. David has over 50 years of experience in fabrication, engineering, erection, and project management of major projects across the United States and in several foreign countries. He serves on the LOD and BXP task forces of Beamform Global. And we have Dr. William Eicher, PE, PhD, is Director of Research and Education at Beamform Global. Dr. Eicher will be moderating today.
Thank you, Luisa. Just so I can do a check, is the screen showing good for everyone?
Good.
Wonderful. Well, it's a real honor to get to be here today, and it's a real pleasure to be with Dave. I have an immense amount of respect for him. He's been a great advocate for change in the industry, and he's also a friend. And we've done a lot of projects together. I come from a structural engineering perspective, and he comes from a detailing perspective. And we'll share a little bit about that. We're going to talk about really how LOD has really advanced. By way of introduction, this webinar is being broadcast by Ascend Building Knowledge Foundation. It was founded in 2017. It's a 501c3 nonprofit foundation and focuses in research and education. With that focus, it's looking at the built environment for architecture, engineering, construction, owners, and their facility management stakeholders. Additionally, the CD-BIM curriculum has been developed by the Ascend Building Knowledge Foundation. Beamform Global is a new sub-forum of Ascend, and it focuses really on people, process, methods, and modeling, and it supports the foundational operating goals of Ascend. Additionally, Beamform Global collaborates with other BIM forums and BIM-focused groups outside the U.S. as well as within the U.S., developing content in multiple languages. Currently, Ascend has funded development of building information modeling and VDC content in English, Spanish, and French. We're going to talk some about that, and it's through partnerships with other BIM-focused groups in different countries. In looking at it, Dave and I wanted to give some background on really some data points in LOD development. I think that gives context for this whole discussion for today. It's always good to know, how did we get here? And so one of the points, this is not all inclusive, and it's really meant to just provide some context. In the US market, the US National Architectural Organization created an LOD specification 2018. Many are probably familiar with that. Along that time, it called out 5 cardinal stages of development. 100, 200, 300, 400, and 500 was as-built. Early on in that process, discussion started emerging of a 350. And Dave and I will both talk about this a little later. Through that time, Mr. Merrifield and I had presented the LOD definition of 350 and proposed it to the AGC BIM Forum. This was around 2012. Following that, the AGC BIM Forum created an LOD specification in 2013. NISD did a lot of work in helping provide content and feedback on the steel section, for example, and really spearheaded the introduction of 350. And the graphics that were created are really, you'll see similarities. These are published works from before in 2012 and before. And that's one thing Dave and I want to point out. When we're working on these LOD discussions, these are real world examples that we're developing from projects. Often we won't tell the name of the projects by name, but this, for example, was from a Formula One track. It's one of the largest and first purpose-built Formula One tracks in the US. And this was a real challenge in the development of that project. And you'll see that this, when we get into it, that this is really what pioneered sections of many LOD specifications that have been developed. This graphic, for example, has been used by a lot of groups to address structural steel. In 2014, BIM for Masonry worked on developing masonry context and developments. This was done in collaboration with work at Georgia Tech, and Jamie Davis with BIM-M really spearheaded a lot of the work there. The Structural Joist Institute in 2015 additionally started working on level of developments of bar joists and steel deck. And moving into precast concrete, PCI began expanding its LOD definitions in the precast arena. Along the same time, groups such as BIMForm Peru, BIMForm Mexico, and BIMForm France started to emerge. In 2017, wood was coming online. Mr. Steve Bumbleow provided a lot of guidance in authoring sections of wood LOD during this time periods and worked on publishing this work. And you'll see, with his permission, that content shown today. As I mentioned earlier, Ascend was formed in 2017, and it's a 501c3 nonprofit. BIMForm Global is a subforum that was created in Ascend this year. In 2017 period on, you saw the Metal Building Manufacturers Association began working on their LOD definitions. By 2019, cold form metal framing and metal studs were starting to emerge. The original LOD national specifications that were developed by the AGC BIM Forum were continued by that organization until 2018. The 2019 specification was published by a newly formed organization in Philadelphia. And the Philadelphia BIM Forum published the LOD specifications in 21 and have not published any 22 specification. Additionally, in 2021, the American Concrete Institute published a technical guide with its definitions of LOD, and they were slightly different than the predecessor ones developed by U.S. national architecture organizations as well as other national specifications. And then more recently, in 2022, a U.S. national architectural organization published updated definitions from its 2013 definitions. So when we talk about LOD, we really have to start defining what people mean and what they're referencing. And one of the things you're going to hear Dave and I talk a lot about in this presentation is a BIM execution plan. And the point of that is that no two projects are identical. No two projects are even in the same location or perhaps even the same country. But LOD is thrown around through many different regions, even within the United States. Many general contractors will write their own LOD definitions, and this can create some confusion. Some will refer to level of detail, others will refer to level of development. And so in doing this, Ascend and BIMForm Global conducted an extensive study this year of what teams are doing, what are owners doing with LOD, what are designers doing with LOD, and what are builders doing with LOD. And from this multidiscipline perspective, it's given us some insight and some of the updates that you'll see in this new version that has come out, published from BIMForm Global. This new LOD specification is being titled version 22. Since there was no national specification published by any group in 22, this one is the version 22, and BIMForm Global's extended the public comment period through the end of this month on that specification. The team is currently doing additions in the areas of landscape, horizontal BIM, and civil 3D type topics. And those will be expanded in a version that will be titled LOD 23. And that will come out at the very end of the year. You'll see when you begin to look at today's presentation why we've decided to go and have an interim LOD 22 publication version. It's more than just that none was published last year. There's a meaningful reason to it. Before we go into the details, I want everyone to just think about the first construction delay claim case they've ever heard of. And the first one for me was the Tower of Babel. And we say, why is that important? Well, why did construction stop? It stopped because their languages were confused. And whether you believe that's a true story or a fable, I'm going to submit to you there's truth in that story. And the point is, just as languages being confused can stop physical construction, it definitely can slow and hamper virtual construction when teams are using different terminology for the same thing. When we think of LOD, I want everyone to be thinking about model handoffs. And a model is a collection of elements at different LODs. And they might think of a relay race. Each runner kind of handles their leg of the race rather well. It's when they're handing off the baton, or in our case, the project owner's stakeholders are handing off the model from one stakeholder to the other. That's where the problems can happen. And a slip of the baton can really hurt that team from being a first place winning team to really being a second-rate mediocre team. When we roll together the updates today, you're going to see there are the 2022 version. That's what is currently out in public comment. And the 23 version is currently under production. And what will happen with the public comments? Over the next 2 weeks, the public comment period will end at the end of this month of August. Changes, comments that can be adopted and incorporated will be. There will also be new ideas. And in those items, they may be more that can be incorporated at the end of this public commenting period. For those items, they're immediately rolled into the 2023 specification. Following this year, we intend to publish the specification each year, as Dave and I have done in other organizations that we've worked with. You might say that we've been preparing for today's presentation for the last decade. How do we get this? You go to BIMform Global/LOD, and you can go to the LOD link, and that will take you to a page. And in this location, there's a form at the bottom of that page, and one is for English, and the other is for Spanish. The French specification is under development currently, and is anticipated it will be out later this year. What is new? Dave and I both had a number of questions about LOD 350, and there's a section in the introduction that highlights the background, and it references publications that either I wrote or Dave wrote or other authors and contributors to this work have authored. The LOD definitions. These are unique definitions. It's based on researching a lot of what different teams are doing with level of development definitions. And I'm going to highlight why this is and why these definitions are formatted this way. Some of it is also to support other countries that may not use the American definitions. Additionally, there's a new single sheet format to this specification. This came from a lot of feedback from over 500 stakeholders that we have interviewed. This would include general contractors, architects, engineers, and trade partners. In looking at this, we came up with this new single sheet format. As we dive into the definitions, you'll find in the introduction a one-page table. This specification addresses the multiple definitions that are out in the industry. And the specification is meant to be compatible with groups such as the GSA, that when you go to their website, they're going to reference level of detail, as well as other groups that are using very common and familiar National Architectural Organization contracts. In doing this, what is distinctive to the BIMForm Global specification is the formation of an LOD 0. And the reason that is important is that there are sometimes elements in a project that will never be modeled. And it is appropriate to have a tool contractually so that teams can exclude that from the process in an LOD table. 100 is conceptual. And one of the things I want to point out in doing this is this definition table. The authors have worked very diligently to get this packed into one page. And many of the sections of this are intended for teams to be able to use in a more intuitive, easy format. The reason this is one page is that sometimes project executives may only look at one page when it comes to a detailed topic like LOD. And so we purposely tried to condense everything as much as possible. Additionally, this is the first specification that is built from the ground up to address tolerances and emerging reality capture processes. So in doing this, we specifically identify in the table if an LOD may accurately be measured from the model. And so at 100, it is conceptual. This definition here is very similar to what you would find in the US with national architectural organizations. This table will clarify whether it can be measured from it, from the model, without referring to any contract documents. The important part of this is to really pave the way for teams using reality capture, where measuring from the model is the very point of creating it. When we look at LOD 200, the keyword you'll have there is approximate. May elements be accurately measured from the model? No. And you'll find that in this table. And this would show you an example here, the steel column. As we move to 300, we're going to note it's specific. And in another presentation later, we'll go over the 10 rules of LOD, and those are highlighted in the introduction to this specification. And I use rules in quotes, but they're guiding principles of LOD. But for LOD 300, an element must be specific within project tolerances for its system. So if it's structural steel, it would refer to the steel specification for tolerances. And Dave will talk some about that later on some of the project examples we're talking about. But it has to meet all of these requirements. So you'll see capital all in the definition, quantity, size, shape, location, and orientation. 350 is going to be enhanced coordination or detailed coordination, and you'll see anchor rods emerge at this LOD. 400 is fabrication level, and yes, everything may be measured accurately from the model within the model element's project system tolerances. So it's very important when I say that this specification addresses tolerances, it's doing it by reference. Depending on your jurisdiction, if you're in the US, you might very well be under the International Building Code, and those are going to reference for steel, for example, the AISC tolerances for steel. If this member was concrete and you're in the US and you're under IBC, it's going to pull in references for the American Concrete Institute. If it's precast, it would defer to the Precast Concrete Institute. And so each of these industries has their own tolerances for their systems. And that's where this specification expands its usability. And we'll talk a little more about tolerances later. As-built is LOD 300. And it's important that an as-built condition is understood that the 300 classification can be based on geometry of an element at 100, 200, 300, 350, or 400. 500 really does not tell you the accuracy of the geometry of the element. And so you'll see, can you measure directly from an LOD 500 element? It varies. If the as-built conditioning is on a rooftop unit, for example, and that rooftop unit was only modeled to LOD 200, but then it has been field verified, then that is an LOD 500 element with geometry based on LOD 200. If it was a structural steel fabrication model, and it was field verified, that structural steel would be based on an LOD 400 geometry. This is very important to clarify. It's an area that we found in interviews of project stakeholders that there's a lot of potentially a lot of confusion around 500. What you'll see, we've talked about the new single page format. This came from feedback from teams that were discussing that when jobs are bought out, they frequently just need 3 or 4 pages. And many of them said, honestly, this could have just been put onto 1 page. And after we heard a number of feedback from that standpoint, we listened. And so you'll see a new single page format. Later in doing this, you will find that LOD 0 is specifically identified. This is an 11 by 17 sheet, and we'll talk a little bit also about the organization of this new specification. When you download the English or the Spanish, the authors have worked on making sure the page numbers reference the same. Additionally, there is some regionality of this, and some of the other BIM-form groups we are collaborating with in Latin America you may see notes in the Spanish edition that say if applies to Peru or Mexico or other countries. There's a lot of jurisdictions when you start to deal with Latin America. But the goal here is if you are dealing with a structural steel column, you have 1 sheet, and that's what you can attach. In the interest of time, we're going to go over a lot of the research that went into these new changes in a second later webinar. It's going to be when we address the 10 rules, again in quotes, the 10 guidelines of LOD. And those were really formed out of the interviews we've done with over 500 general contractors, architects, engineers, and trade partners, as well to throw into the mix some construction attorneys. On the format, you will find that in the table of contents, it's listing these sections. And I do understand this is small print. There is a section for masonry, and there are approximately 3 or 4 pages, sheets following the section sheet for masonry. If you are working with a masonry trade partner, then that's all they really need to attach their contract and reference the rest of the specification. But when they're talking with their team, everything is in one place. They do not need to flip over to an exterior masonry section and then find an interior masonry section and then look at a veneer section. Everything that the mason needs is in one place. If you are working with structural steel or miscellaneous metal, it's all in one section that's easily attached to your contract or your buyout documents. And if you're dealing with the stakeholders in a meeting for structural steel, or you need to email out the steel section, there are a handful of sheets, it's a condensed packet, and it's very intuitive and easy for people to reference. If you're dealing with cold form metal framing and drywall sheathing, there's a section for you. If you really look at how a job is typically bought out, the specification is organized for those stakeholders because the general contractor or design build partner leading the team needs to look at costs, and those costs are normally associated by systems. With that said, the specification still references all of the popular industry classification systems. Dave, could you talk a little bit about tolerances in here? And because you're coming in from NISD with a lot of perspective on the steel detailing side, which is probably kind of an intolerant material, if you think about it, compared to things like civil utilities that can be off a foot or so. But talk to us a little bit about tolerances with structural steel.
Well, in the modeling world, there in fact are there are no tolerances within the model. When you're modeling a particular column, it is exactly what its published size is. That doesn't mean that it is in fact that size when basically you purchase it and put it into service. There is rolling tolerances that basically define the fact that the member can be either thicker or a little wider, or the flanges can be offset. There's world is not necessarily perfect, but in fact, in structural steel, we have defined tolerances that basically we think about and deal with. But from a modeling perspective, a 12-inch column as published is exactly what it shows in the model. But
That's a great point. The models are always precise. They may or may not be accurate. And one of the things we've talked about before, Dave, is also construction tolerances. How thick is fire protection around the steel? What about deflections? If you've got a girder in a hotel, that like a ballroom condition where a 60, 80-foot spanning girder is supporting columns from multiple floors above, it's going to deflect as the building is constructed. And you may initially have camber. And so, Dave, are you seeing any of the detailing platforms even address things like camber or deflection as you're doing the detailing?
It's interesting that I'm working on several projects where, in fact, that exact question came up, and in basically what you're dealing with in camber for the most part is you're dealing with a dead load deflection that, in fact, if you're going to erect a truss, by the time when you erect that piece, that's probably that camber is not going to be there. There may be some residual, but the reality is that it's as if it was a flat structure. There are times when we deal with that where, in fact, it may be important that that camber is in fact built in, so that in fact that it does in fact not the model would have to in fact include that, but that's generally not taken into consideration when building the model. You're pretty much building it as its final position would be.
Well, and then also, Dave, kind of give us a highlight when you're even looking at the steel package, when you look between bar joists, handrails, stairs, structural steel, miscellaneous steel, are those by the same company typically? Or is that really like divided up against a lot of teams?
Well, it depends upon how the construction company may or may decide to split it up. Obviously, bar joists aren't generally produced by a normal steel fabricator. A fabricator that's only doing structural steel may not, in fact, do all the miscellaneous or stairs and rails or other items. So, in fact, you could have a structural steel or a steel structure where you may have 4 or 5 different companies that are supplying models. So basically, you end up with a federated model within the steel structure itself.
Right. And so just within steel, you could have potentially 5 companies with 5 different modeling teams, and things such as bar joists are almost never at LOD 400. And I want to repeat that. They're almost never at LOD 400. And so the reasons for that is that if you're welding on those bar joists, the second that bar joist leaves the factory, it is no longer the responsibility of that manufacturer. That's a manufactured product that's leaving one stakeholder that took their model to LOD 350 in many cases. Then the erector is placing those bar joists and welding them on, and they're putting the miscellaneous steel out into the field. Most conditions, and I say almost never, there's, I'm sure, always an exception, but most conditions, that bar joist manufacturer is not privy to the geometry it would take to take that bar joist to LOD 400. And so sometimes when I'll see general contractors, for example, and they're talking about steel, they'll wrap up all the steel model in their mind as one modeler, one stakeholder, and it can be fine. It can be very nuanced. And so the contracting and buyout, there might be one contract for the fabricator, for example, but they have sub fabricators under them, perhaps. Even just within one system of quote unquote steel, you really see it could be up to 5 different systems with 5 different companies that each may have slightly different LODs for their particular steel component in that mix. Dave, I would say this could actually be a topic for a whole new webinar just on tolerance. And I say that based on you and I actually having done one at the North American Steel Construction Conference in the past. And so I think we're going to be revisiting it again. So if this is a topic you're interested in, please give us feedback. We want these to be informative and helpful, and we also want to learn how to make them better. The reason we've touched on tolerances is from Ascend's research in the industry, which would include work in data in Canada, as well as Latin America, and definitely predominantly in the United States. We're starting to see reality capture expanding, and the tolerances of the technology are growing. And as we look on that, tolerances start to become a real issue in the model between the point cloud and the model. And so this is yet another webinar for a different day, but the level of acceptance specification addresses that, and it is made to work in tandem with the BIMform Global LOD specification we're addressing here in this presentation. This is an area that's very interesting and near and dear to my heart after 20 plus years of working in industry as a licensed professional engineer and scanning a lot of buildings. I made this the focus of my PhD at the University of Denver. And so we'll be diving into this one deeper, but this is an area I really see as a missing link in the evolution of parametric modeling for construction. It's something that aerospace and manufacturing has really excelled at, and now we're getting the kinds of speeds and computer power and capacity to bring the price points down where reality capture is very prudent, and it's almost irresponsible on some projects to not consider it. But we need a way to clearly specify what is needed in those regards. And that topic of tolerance is intimately intertwined with the discussion of LOD. And so that's why from the research we've been doing at Ascend, we've really seen that the need for these two items have to be addressed together on projects moving forward. This one is a example of a project. What Dave and I are going to do is just kind of talk through different examples and talk how the LOD spec would be used. This is a project I'm more familiar with. This is an incinerator project. Had some anchor rods not installed in the right place. And as we talk about this, these anchor rods you see here in this image, those are 3-inch diameter. This is on top of a 20-foot by 20-foot pedestal that's 13 feet tall, solid concrete. This is what a massive incinerator sits on. These are approximately 40-inch deep girders and with train rail on top. And the train rail is what the door of this incinerator rolls back on when they go to open it. And then there's a lift that brings things up, puts things into the incinerator, and downstream it has about 160-foot tall stack. These are very large projects. And so if you get an anchor rod off, it's a showstopper. And you don't just field bend a 3-inch diameter anchor rod. And so laser scanning became important, but part of the specifications in this was anchor rods to LOD 350 with a tolerance and referenced AISD tolerances. And so this would be an example of how the LOD spec is used in tandem with reality capture. In the interest of time, I want to get to some of Dave's projects. This one's a historic project. This was a project in San Antonio. And the point here is this is existing construction. The incinerator was new construction. This is 1928 building that had about $135 million new addition added to the center of it, but keeping all of the existing 1928 structure and architecture on the facade on 3 of the sides. It's kind of a circular shaped item. Dave, this is a new construction example. What project is? Talk to us about this project.
This was a project where, in fact, it was we provided not only the fabrication, but in fact the model for this project. But what happened with this thing is kind of interesting, and it tells the good story about tolerances and what happens between trades who don't understand each other's problems. So in fact, we had fabricated all the steel for this project, and it was sitting on site. And after 5 weeks of not being able to erect, the problem turned out to be that the anchor bolts were not placed within what I would say a reasonable tolerance. The problem with anchor bolts obviously is a steel fabricator, and their detailing partner will take them to level of LOD 400, but they get shipped to the field and they're replaced by a concrete subcontractor who basically has their own set of tolerances and their own set of problems. So what happened on this job is that after about 5 weeks of the steel setting on site, we decided that the right thing to do was, in fact, to have all the anchor bolts on this project scanned, and then basically take that back into the model and be able to determine what needed to happen at each location to be able to get the project back in so that it could be erected.
One of the things I took note that you were telling us about this project, Dave, when we were preparing for this, is your fabrication site's 6 hours away, and this owner doesn't normally let any torching of steel occur on site at their facility. And so talk to us about some of the cost ramifications about the solution you developed on this one.
Well, what we were faced with was picking all the columns up and shipping them back to the to the plant and modifying the base plates. Sometimes, maybe taking them off and putting them back on. Obviously, a pretty expensive process.
And part of the solution here you came up with, and that would have been a change order to the owner based on, or at least to the general contractor, based on the shortcomings of concrete trade in this example. But talk to us a little bit about how you helped the owner out with a new solution.
Well, we obviously went out and found a really good subcontractor to be able to laser scan the anchor rods. And this was early in the process. I don't remember exactly what year this was, but this was really early in the
the use of this technology.
The process where laser scanning wasn't being used all that commonly on projects. But anyway, we sat down with the contractor and worked it out. Obviously, we had to go back in and establish new survey points, so in fact our model fit in fact the where all the column center lines basically were supposed to occur, and basically the process worked very well. We treated it as a clash detection process, where in fact we put the anchor rod scan back into the model and was able to locate exactly where they were, and it took about 3 days, I think, over a weekend to be able to accomplish this and then get the project back on track. And we simply sat down with the contractor, the concrete sub, the erector, and the owner, and went through each location and made decisions about what needed to happen at each location. And in about a half day's time, we had reached solutions and were able to get the project back on schedule.
Incredible story, incredible project. One of the takeaways I have here is this would be an area where the anchor rods would be specified to LOD 350 modeling, and the laser scan provider would be given tolerances that those anchor rods needed to be within. These are examples of model extraction. So that is an as-built anchor rod. So LOD 500 as-builting with a geometry based on 350. So I want everyone to get comfortable with that terminology, because it can be a little jarring if you haven't really thought through this. 500 doesn't specifically tell you anything about the accuracy of the geometry. And so that's why when you're dealing with as-builting and 500 model elements, you need to clarify, is the geometry based on 350 or 400 or 200 or 300? In this example, for what Dave needed to cut new openings or enlarge openings in base plates, he did not need the threads on those anchor rods. He did not need the portions of the anchor rods that are cast into the concrete. He really was concerned with the anchor rods protruding out of the concrete that he had to interface with. And that's an important point because technically speaking, those anchor rods could not be modeled to LOD 400 fabrication level with just laser scan data. And the reason for that is the laser scanning can't see through the concrete. As we look at other examples of this, the key points here are AISC tolerances. Additionally, if teams are specifying things like anchor rod scans, it's frequent to have pockets that the anchor rods are in on projects. And one of the things you have to always think about there is debris. These turn into like little trash cans over your entire job site. There are also buckets that collect water when it rains. And laser scanning can't see through trash, nor can it see through water. It will reflect off the water. So one of the things, if you are thinking about using this kind of approach on your projects, you need to consider in there who is cleaning out these column base plate pockets and who's vacuuming them or getting water out of them, because that's a frequent problem. This is an example from the incinerator project I was on. Fortunately, this section of the steel had not been fabricated yet, but you could see these are as-built anchor rods, and this one was just a detailing adjustment. A change had been made in the design and not communicated. So this is an example I point out because the design model had many elements at 300, but this particular column, while looking very precise, was in the wrong location by about 3 feet. And so it goes to underscore one of the rules of LOD is that there's no LOD for a model. A model is a cocktail of elements at different LODs. What is this job, Dave? This looks like an interesting canopy.
This was, in fact, a job. They wanted to add a canopy to existing hospital. This hospital was probably 50 years old. That what you're looking at is cast stone, and they wanted this canopy to be able to fit the scallop nature of the front of the building. So when I first looked at this, I realized that with all the different elements and how this had to go together, we could detail it and fabricate it, but it wouldn't necessarily fit the building.
Yeah, you get it just precise. It just may not be accurate.
So in fact, when I first looked at this thing, I decided that laser scanning the building and the different elements that were in place was in fact the first step before we could ever start to even model it.
One of the things that came out in the case study that I noted is there's air shafts here coming up from below parking garage. What is in green here is the 1950s facade, and then gray is the new structural steel. You can see the type of foundation systems that would be cast in out in the sidewalk area, which is above parking garage below. And then what kind of architectural finishes did this have on it, Dave?
That basically had a metal roof and a metal fascia system. What you're looking at there was in fact the overlay of the roofing supplier and the people making the fascia material. That was their model, and obviously we had to come together to be able to make the two match up. They were having their own problems, so you know that picture in the right corner there basically is showing a metal fascia system and roofing system that basically didn't fit the structural steel. So that also had to be taken into account, that all this needed to be prefabricated so that it in fact could be erected and put in place fairly quickly.
Yeah, part of the case study, this is a sloping architectural metal panel system. And originally, that trade partner only did their shops in 2D. The top of steels were actually called out in the structural drawings. And so the steel fabrication model was dictated and locked in. And this is an example of, it's a canopy, but there's the architectural finishes that in this case are LOD 200, and the structural steel is all the way to LOD 400. And so what we wanted to point out in this case study is even something such as a canopy is going to be a cocktail of elements at different LODs. And I think that's something that it's one of those 10 rules you'll see in the introduction. But in looking at that, there is no LOD of a model as we look at that. And Dave, what are these? I guess these are plan views.
The interesting thing about this is that what we not only gave the design drawings to the detailer, but they had to learn how to use laser scan image to actually detail the structure, as opposed to just detailing it off the structural drawings.
Yeah, and so in this one, an LOD 200 reference model of the enclosure was created. And it's important that it is noted it's LOD 200 because it was approximate. There's no way that the modelers would be able to model it to LOD 300 on an existing building that they have no knowledge of what the real core of the wall is. In this case, no scan of both sides of the wall. The scope was to scan the outside. From those perspectives, it would be inappropriate to require laser scanning to provide an LOD 300 element, or worse, improperly state, I want an LOD 300 model from the laser scan. What you're doing in most cases with most sets of LOD definitions, if you write the statement in your contracts that I want an LOD whatever model, you're asking for a unicorn that doesn't exist. A model's this cocktail of elements at different LODs. And particularly with laser scanning, from our research in interviewing teams, one of the things we see crop up often is when teams are mixing the LOD terminology with reality capture for scan to BIM. And there is defined grammar when it comes with LOD in writing the scope, schedule, and fee. And additionally, when construction litigation does happen, everything goes back to that defined grammar for that project, for its BIM execution plan, hopefully if it exists, and the LOD definitions that are in it. And so particularly as reality capture begins to expand in usage, this is a good case study to think about. This one's one of the case studies I did research on. This was an early on post-tension scan. This was probably circa 2013. What's interesting in this example is, for those of you who are familiar with post-tension concrete, you hardly ever see a slab in this condition, such as the photo. This is the day before the pour. That's when everything is really getting in there. Their last of the rebar is going in. Electric pulled boxes, electric conduit are getting checked. Tendons are in. And there's just a very small window of time when this ever actually happens, and it's the day before the pour. You have rod busters, those working on formwork, the placers of the rebar, electricians. This was an elevated deck for a parking structure that would have retail space built on top. In that condition, you're really dealing with a moving formwork from people walking on it and throwing rebar around and tying steel and blowing off dirt. And so that's why there's so much noise in this laser scan data. It's because the scanner is vibrating from ambient vibrations. So the tolerances are not going to be anywhere near the published tolerances of the scanner. These scanner published tolerances don't assume you're on elevated deck formwork that's being shaken while you scan. And so specification requirements need to identify that. So additionally, because of the way the formwork's locked in, its vibrations are predominantly up and down, not side to side. At least you hope. Side to side would be very bad, perhaps catastrophic for formwork, but it's very common to get vertical vibrations when people are walking on it and placing materials. And so the tolerances of that PT tendon in a horizontal direction are much more accurate than its tolerances in the vertical direction as it's moving up and down with the rebar it's tied to. So the specification that you'll find with BIMform Global gives you an easy framework to identify tolerances, both horizontal and vertical, in your specification. It can be done in one table per item, and then it references over an LOD that ties into the BIMform Global LOD specification. Again, rebar, modeled at 350. Tendon, in this case, rebar taken some of it to 400, but tendons at 350. You'll notice these tendons are not all fanned out, but this was really just to check constructability before a concrete pour. I'll point out this is what the designer showed, and this is what it really looked like. And there was not enough room. There's additional electrical conduits that were supposed to go through there. There's just not enough room to build this, and that led to a design change in how it was detailed. Dave, I'm looking at our time. We obviously have a lot more material. These will be in the slides we'll share. What I will say is when you get a model, it's going to be a mixture of elements at many different levels. And I'd leave you with this thought from Socrates: the unexamined life is not worth living. And our corollary would be the unexamined construction documents are not worth constructing, and the unexamined building information model are not worth building. Dave, I really want to thank you for your time. And as we look forward, next week's webinar, we are going to have guest speaker Matt Sweeney. He's a professional engineer in the Southeast, and he's been doing some progressive work with design build teams. And we're going to be looking at tilt wall. And this is one of those interesting elements that the window openings are the domain of the architect. The parapet is the domain of the architect. The reveals, domain of the architect. The bottom of the wall and how it connects to the foundation, it belongs to the structural engineer. The thickness of the wall and the reinforcing in it belong to the structural engineer. And the mechanical penetrations for roof drains, for example, coming in, with the cow tongues attached to the facade, that's the purview of the mechanical engineer and then the plumber, in this case, MEP, but specifically the plumbing. Mechanical louvers. If this is tilt wall that's being used on a public school, for example, that must have tornado resistant design, there's a lot of coordination that goes into those mechanical louvers that have baffles that can handle closing off in a tornado event. And so with this just one element, tilt wall, who owns it? And the answer is, in some projects, everyone. There's electrical penetrations, there's plumbing penetrations, there's mechanical penetrations. Half of it's the structural on the thickness and the base of the wall, and the architect has the reveals, the openings, and the parapet. So there's more to it than just saying it's a tilt wall webinar. There's really something in there for everyone. And ultimately, the contractor has to coordinate all that. But this webinar will also highlight the merits of design build. And if you get an entire team aiming at something, they'll hit it. And if they aim at nothing, they'll also hit that every time. And so we're looking forward to that. With our time, Dave, we are now at 11. Luisa, thanks for introducing us. And Dave, thank you so much for your time coming out of Colorado.
Thank you.
These PowerPoints will be available to contributors of Ascend and BIMform Global. And we're also going to be posting this recording for viewing later to those who are contributors to the organization. We really appreciate your support, and we definitely want your feedback. Remember, when you, to get the LOD spec, it is free. And in addition to that, if you just keep downloading it, it's volume discounts. So tell everyone, you go to the website, you enter your name and email address. We do not share that, but it does help us know globally who's downloading the LOD spec and where it's being used. And there is a link within the spec at the base of the page. There is an address there where you can provide feedback on the page. When you hit this link, it'll bring up a web form and you can comment. And one of the things, Dave's a principal investigator in the LOD spec for BIMform Global, as am I, and I'm director of research and education. And we always remember Oscar Wilde's quote, "True friends stab each other in the front." And so if there are things we can do to make this better, we want to hear from you. Probably more so than others that say, "Hey, this is great." We really appreciate critiques. And with that, Luisa, I guess we will sign off, and I'll stay online to answer questions if there are any. But thank you again, everyone.